Hello again. In this video, I'm going to go over section R6, which is about rational expressions and more operations on radicals. Now, there are 6 objectives in this section, and in this video, we're going to focus in on the first one, which is about determining restricted values for a rational expression. Okay, so the first thing I want to do is talk about what it means to be a rational expression. So, a rational expression is simply a polynomial divided by another polynomial. Now, one way of remembering this is rational has the word ratio in it. And so that might remind you that it's the ratio of a polynomial to another polynomial. Now, we are going to run into some issues with these rational expressions. Oftentimes, these rational expressions are undefined for certain x values. And so that's what we're going to do in these 3 examples. Here we have 3 different rational expressions. And so for each of these, we're going to try to determine for which x values the rational expression is undefined. And in this last example, we're actually going to find the x values and the y values where this rational expression is not defined. Okay, so let's start with this first one. So notice this is a rational expression. This is a first-degree polynomial divided by another first-degree polynomial. And so this is a rational expression. The thing with rational expressions, though, is oftentimes they don't always exist for all values of x that you plug into them. So for example, let's say you plug a 4 in for x, right? If you plug a 4 in for x, you get 1 over 6. 1 over 6 is a perfectly fine number. There's nothing wrong with that. But if you plug a negative 2 into this for x, notice that you get negative 5 divided by 0, and there is a problem with that, because negative 5 divided by 0 is undefined. We don't know what it means when you take a negative number and divide it by 0. In fact, we don't know what it means when you take any number and divide it by 0. Division by 0 has no meaning in mathematics. We don't know what it means, right? It's undefined. Okay? It's not a number. And so for that reason, this rational expression is restricted to only x values where you actually get something defined out, okay? Okay, so the way you would know this is what we're going to do is we're going to set the denominator to 0 to find out when that happens. So I'm going to take x plus 2 and set it equal to 0 and try to figure out for which x values this is equal to 0, the bottom, the denominator. Okay, so if you solve for x, just subtract 2 to the other side. You can see that x is equal to negative 2, which is what I mentioned up front, right? If you plug a negative 2 into this rational expression, you get negative 5 over 0, which is not a number, right? It's undefined. Okay, so this is the restriction. X cannot be, is not equal to, right? It cannot be negative 2. That's how this is restricted. So for this rational expression, you can plug any number you want in for x, and you'll get a number out. But the minute you plug negative 2 in for x, you get negative 5 over 0, which is not a number. And so we say this rational expression is restricted. You're not allowed to plug in negative 2. X cannot be equal to negative 2 in this rational expression, okay? Okay, so let's look at this next one. So again, the issue is I can't divide by 0. So I'm going to take the denominator and set it equal to 0 and find out when that happens. Okay, so to solve this, notice this is a binomial. And what we're going to do is we're going to factor it. This is actually the difference of squares. The square root of 49 is 7. So you can think of this as 7 squared. That's the same as 49. So if you remember in the difference of squares, a squared minus b squared is equal to a plus b times a minus b. Okay, and in this case, a is x and b is 7. And so this would factor into x plus 7, x minus 7. And then if you solve this for x, what's happening here is we've got two numbers that multiply to 0. So just imagine taking two numbers and multiplying them up and getting 0 out. If this is going to happen, I claim that one of these numbers would have to be 0. You can't take 2 times 3 and get 0, right? That's 6. But if you take 0 times 3, you would get 0. Or if you said 3 times 0, you would get 0. One of these two numbers in these boxes would have to be 0. We don't know which one, but one of them has to be. That's the only way to get a 0 here, right? So by that logic, this is a number times another number. If I'm going to get, when I multiply these together, if I'm going to get a 0 over here, then one of these numbers would have to be 0. So either this one is 0 or maybe this one is 0, but one of them has to be 0. Okay, and so if you solve for x here, add 7 over to the other side, you get x is 7, and here you would subtract 7 to the other side, and you get x is equal to negative 7. And we can double check this. When I plug 7 into here, 7 squared is 49. 49 minus 49 is 0. Okay, and by the way, you should plug 7 in for this x value too, so you get 7 over 0. So when I plug 7 in, this is 7 divided by 0, which is undefined. When I plug negative 7 in, I get negative 7, and then negative 7 squared means negative 7 times negative 7, right? That's what that means. And when you multiply a negative by a negative, you get a positive. So that's positive 49, and then 49 minus 49 is 0. Okay, so when I plug negative 7 into here, I get negative 7 divided by 0, which is also undefined. Okay, so there's two restrictions in this case. X cannot be negative 7, and x cannot be positive 7. So that's the restriction for this rational expression. You can pick any other number you want for x. You can't pick it to be 7 or negative 7 though, because you don't get a number out when you plug those in to this rational expression. Okay, let's look at part C. So again, notice this is a polynomial divided by polynomial. The top polynomial, by the way, happens to have degree 0. That's a degree 0 polynomial. And the one on the bottom has degree 3 because the exponents for this term add up to 3. Okay, so that's a third degree polynomial. Okay, so this really is a rational expression. It's a 0 degree polynomial divided by a third degree polynomial. And we want to know what the restrictions are for x and y. So again, we're going to do the same thing. We're going to find out when the denominator is equal to 0. Okay, so we just set this equal to 0. And then we're going to solve for x and y. Now you can divide both sides by 5, and that'll cancel this 5 out. And then on this side, 0 divided by 5 is just 0. And now we're left with the same situation that we had here. X squared is some number, and y is some number. So I'm multiplying two numbers together, and I'm getting 0 out. So that means one of these two has to be 0, either x squared or y. Now, if x squared is 0, the only way that will happen is if x is 0. Okay? If x is any other number other than 0, then when I square it, I'm not going to get 0. For example, let's say x was 3, right? 3 squared would be 9. Okay, so there's no way for it to be 0 other than the case when x itself is 0. Okay, the only time x squared is 0 is when x is 0. And so we end up with two answers here. X is 0 and y could be 0. Okay, and you can check that. If I plug a 0 into here for x, 5 times 0 squared times some other number y, whatever it is, that's going to be 0, right? If I multiply any number by 0, it's 0. And the same thing is true if y is 0. If y is 0, then 5 times any number squared times 0 is going to be 0. Okay, so in both cases, when you plug 0 in, whether you plug it in for x or y, you get 4 divided by 0, which is undefined. And so for that reason, the restriction is x cannot be 0 and y cannot be 0. It just doesn't make sense when that happens because you get undefined out. Okay, so that's the restriction for this rational expression. Okay, well, I hope this video was helpful. Thank you for watching. Bye-bye.